Okay, so this video is about percent composition. Remember that percent composition, we are asking what is the percent of each element in a full compound. So the formula is mass of the element you are looking for divided by the mass of the whole compound times 100 because it is a percent. So let's do two examples. Okay, so the first example that we have is a compound is composed of 4.8 grams of carbon and 0.40 grams of hydrogen. What is the percent composition of each element in the compound? So this problem is asking you what percent of the compound is carbon and what percent of the compound is hydrogen. So remember, the formula is mass of element over mass of the entire compound. So we have the mass of each element, it's given to us, but we do not have the mass of the compound. So what we are going to do is add up the grams of carbon plus hydrogen to get the total mass of the compound. So when you do that, 4.80 grams plus 0.40 grams, you get a total of 5.20 grams for the whole compound. So that is our mass of the compound. So now that we have the mass of the compound, we can get the percent composition of each element. Okay, so let's find the percent composition of carbon first. So we know that carbon has 4.80 grams and that the total compound is 5.20. So that is the mass of the element carbon divided by the mass of the compound. And then, of course, because it's a percent, we're going to multiply it by 100. So you type that in to your calculator, you should get 92.3% carbon. All right, so that is how much carbon there is in this compound. Now we need to figure out what is our percent hydrogen. So again, it's the same formula. Hydrogen's mass was given to us as 0.40 grams of H divided by the total mass of the compound, still 5.20 grams. We multiply that by 100 and we get 7.7% hydrogen. So in this compound, 92.3% of it is made up of carbon, and 7.7% of it is made up of hydrogen. So that is our answer. And just to make sure, our two percentages should add up to 100, which they do. There is one other way that you're going to see percent composition. So in that problem that we just did, you were given mass. But sometimes you'll just be given a formula, and no mass is given to you. So instead, we are going to be using our molar mass. Where do you find that molar mass? On the periodic table. So we're going to take our formula, zinc phosphate, and we are going to add up all the atoms, individual masses times how many there are to get the total mass of the compound for zinc phosphate. So when we do that math, we end up getting 386.08 grams per mole for the whole compound of zinc phosphate. So that gives us our mass of compound, but we still need mass of element. So we are going to use molar mass again. Let's say we're trying to find the percent composition for zinc. Well, we know based off of the periodic table that zinc has a molar mass of 65.38, and we know that in our compound there are 3 zinc atoms. Then we divide it by the compound's molar mass that we just calculated, and we still multiply by 100. It is the same idea. This problem, you need to use your molar masses. If grams are given to you in the problem, then you need to use the numbers given. So 2 ways that you can do percent composition. So when we type that into the calculator, our answer ends up being 50.8% zinc. We can do that for our other atoms. So here's phosphorus. So phosphorus, we know from the periodic table has a molar mass of 30.974, and you need to look at how many there are present. This 2 gets distributed to both the P and the O, so we actually have 2 phosphorus divided by the total mass of the compound again, times 100. Plug it into your calculator, and you should get 16.0% phosphorus. We have one more element, that is oxygen. So for the last element, oxygen, we know from the periodic table, again, that the molar mass of oxygen is 15.999. Oops. But how many oxygens are in this compound? Well, you must multiply 4 times 2. So there are 8 divided by, again, the total mass of the compound times 100. And that should give you 33.2% O. So if you take a look, all of the percents of each of these atoms should add up to 100. That's percent composition.